We're from Michigan State University. We go to schools all across the state of Michigan. We go to library events like this. We do things everywhere, and we like to do science shows. So, our favorite things to do, we'll do stage demonstrations, where we'll call really big demos. We'll do hands-on things like this, where you guys will actually get to play with the things and see the science yourself. So, before I continue, my name is Patrick. I studied physical science at Michigan State, which means I like physics and chemistry.
And I studied computer science at Michigan State.
She's the really techie person. So if you have computer questions, ask her. Otherwise, we are going to start the show, but I have a question for all the kids. Do you guys like science?
Yeah.
Oh, come on. Let's try that again. Do you guys like science?
I can see you guys have already been spinning the tops. If you spin them really fast, you notice for the black
You
one.
notice that there's a certain pattern on it and it looks really neat. And since it's spinning so fast, it makes it look as if it has different colors on the black one.
You're right. Which colors do you see on the black one?
Well, I see blue, yellow, and red, and black.
Yeah. And if you spin the blue and red one, what do you see? If you spin it fast enough, do you see
A really cool pattern.
Okay, what are you guys doing? What's happening? Tell me what's going on.
Mine looks like a ring.
I know. Try it the other way. Oh, you have yours in a hole, Brody.
What do you see, Sophie?
There's purple in the middle, I see.
And here's what I want you to do.
It's going backwards.
Is everything going the same way?
Yeah, they look like they're going different ways. Yeah.
And in the middle it looks like
What's with the black one?
I have no idea.
Well, the black one, look at it.
So, what I'm going to need you to do is take the tube and hold it in the hand that's on the side of your black dot. And then look through the tube at the black dot and take your hand like this and put it next to your tube. And look straight at the black dot. You see a hole in your hand? No, take it like, put your hand just like this. And look through the tube, the black dot. Does it look like there was a down underneath? Isn't that funny? Why do you guys think it looks like a hole in your hand? You see it?
like that. And then you can see a hole in your hand.
Yeah, isn't that funny?
Hole in your hand.
Where did your hand go? Where did that piece of your hand go?
You angle it on the dot, and then you put your hand like that. It's supposed to, like, there's a hole in your hand.
When you put the styrofoam in here, yeah, you saw it melt down, right? What happened is that the acetone reacts with the styrofoam and breaks it. And styrofoam is made mostly of air. Like this block here has a lot of air in it. But when you put this in here, as it breaks, all that air gets released, which is why it takes up just a tiny amount of space compared to how much it took up before.
Interesting. So when it goes into a landfill,
Usually when styrofoam goes into a landfill, it'll just sit in there, it'll take up space, and it won't break down because with your gloves. Yeah, with your gloves. You don't want to touch it with your hands just because acetone will dry out your hands really fast. But this, like in a landfill, styrofoam won't break down. It'll just sit there, it'll take up space, and that's bad. But if they want to recycle styrofoam, they'll basically do this. They'll have a giant vat of acetone, and they'll take all the styrofoam they want to recycle and just drop it in there, and it melts down and takes up a tiny bit of space. And then from there, they can either turn it into more styrofoam, which is all they would have to do is grab some of this gunk out and pump air back into it as they shape it into something, and it'll remake this. Or what they can do is that they can just recycle it into a different kind of plastic.
So if we remove the acetone from this, what does that become?
Plastic. It'll just be a hard block of plastic.
Okay.
Yep.
Very cool.
It looks kind of like a slice of pizza.
Yep. So your turn. Put your piece in.
There it goes.
I don't like small permanent residence. Wow.
Yep. So what's in there is acetone.
Smells like
And-
nail polish remover.
That's exactly what it is, yeah. Nail polish remover is just acetone. So I want you guys to think about why that's happening. If you want to touch it, you can use your glove hand, but you have to do it one at a time, and you can't take it out of the bucket. It has to stay, well, in the bowl. It has to stay in the bowl. Okay? So what's happening is this. While this is spinning, you didn't think of the spin as making a circle, right? Now while it's spinning, and if it's spinning fast enough, at any point on that circle, the ball is moving at a 90-degree angle or at a right angle to where the bucket is. So the ball, if my hand is the bucket, while the bucket's spinning, the bucket is spinning up here. The ball is actually moving that way. So then also, if the bucket is, say, moving down like this, the ball is moving straight down, right here. Down here, it's moving straight behind you. Yep. It's centripetal force. Because at every point on a circle, there is a single line you can touch that point and no other points because it's perpendicular, which just means it only touches the one point. It doesn't curve. So that's the same reason why if say you were to try to throw a ball forward, if you're going to throw a ball forward and you're spinning your arm like this, would I want to let go here? Or would I want to let go here? Here? Well, if I wanted to go forward, if I let go there, it goes up. And that's because at that point, while my arm's spinning, the ball's moving straight up. But if I wanted to go forward, I want to let go there. Because right at the bottom, the direction is So, can I get everyone's attention one more time? I just want to make sure we get a good response for this. Do you guys like science?
Yeah!
Alright. Thank you guys for coming. I hope you guys enjoyed the show.